Hi and welcome back to FreeEduHub. As you know, we are covering a course on cloud computing. This is our second session and we are going to talk about elastic computing advantages. So in this chapter, we'll see some of the basic things that we have in cloud computing. First of all, we'll talk about multi-tenancy in the clouds. So in a cloud computing, multi-tenancy means that multiple customers of the cloud vendors use the same computing resources. Despite of the fact that they share the resources, cloud customers are not aware of each other and their data is kept separate. Now, in order to understand it, we can think of the services like Dropbox or TeamViewer, etc., which we use on daily basis. Dropbox is used in order to share the things or in order to save your stuff in a cloud storage, whereas TeamViewer is used as a remote desktop support and solutions, etc. Now, if you as an organization is subscribed with TeamViewer, you'll be able to see only the computers and people related to your organization only. So it's one application which is used by different customers, but only you as a customer will be able to see the data which is related to you and your organization. So that's single tenancy and multi-tenancy. If you want to have a complete application which is dedicated for you and no one else uses it, it's a single tenant. If multiple organizations are using the same application but the databases of each of them are separate, we call them multi-tenancy. Just like in the picture over here, as you can see that there are different customers, they are using the same application, but their database is totally separate and each instance of it is installed as a separate application. Now think of it in a organization or an enterprise environment. If you are segregating the same application separately installed for each department, you'll not have one database through which you can share the information, or you'll have to deploy the application at different levels for different departments. Whereas in multi-tenancy, there will be one application, database will be different for each customer, but all will be able to get the same interface through which they will be accessing their own data. Now in this kind of setup, the ease of use is that we can have only one application, just like in multi-tenancy. We'll update this one application and everything will be updated for all the customers and their data will be saved separately in their own respective databases. Whereas if we'll have the option of single tenant, we'll have separate installations of each application for each customer. Whenever there is a change, we'll have to change the application for each customer, and of course their data would be going to the separate databases. Now the advantage is it's better for resources, ease of scaling and maintenance, optimum efficiency, and effortless onboarding. So it gives us lots of advantages if we have a central application and different databases for each customer so that all of them can enjoy the features of the cloud computing. Now on the concept of elastic computing is defined as the ability of a cloud service provider to swiftly scale the usage of resources such as storage, infrastructure, memory, CPU, etc. up and down to meet the workload requirements dynamically. So it would dynamically expand to the resources that you have agreed upon. Now advantages it pay per use feature, cost effective and flexibility, and on-demand computing. So that's elastic computing. It has elastic scaling, it has load balancing, and it has mirroring. Now you'll have to choose an option of elastic scaling, otherwise it won't automatically scale up to the resources. The main feature or the main benefit of elastic computing is, take an example of a registration period in an academic environment. Now you have some dedicated servers, for example, on premises. The problem during the registration, what happens is that if you have 10,000 students and all of them would try to register at the same time, during the registration period, your servers might get slow because they are not powerful enough to cater the needs of all the students who are trying to access the database at the same time simultaneously. So the option is that you'll have to upgrade the infrastructure, making sure that the new infrastructure is capable of handling 10,000 students at the same time. But we'll have to consider that you'll only have this spike once, twice, or even thrice in a year. Otherwise, your utilization of the servers would remain at the normal level. But during the registration period only, you need the extra resources for those computers. Now it's not viable to invest a lot on those servers just for the registration period, and for the rest of the year the servers would be working on their normal capacity. So in order to overcome that, we have an excellent thing in cloud computing that we can enable, or we can allow the automatic scaling option. So your server would perform according to the current specifications, like a lower end, which is required for it to cater the needs of everyone in a normal semester. But during the registration period, you can enable the option of auto scaling. So if there is more load on the server, it would automatically expand its resources to cater the needs of all the students who are trying to register the courses at the same time using the same registration system. In that way, the customers will not have to wait for their turn. There will be no slowness of the resources or the response time from the server. Everyone will be served, and once the registration period would be over, it would scale down automatically to its original capacity, which was agreed upon. Now in that case, what happens is that the cloud service provider would charge you only for the time till the time you will be making use of more resources, or when it would scale up automatically. It would be calculated as per the number of hours or minutes that you have consumed that service, and then it comes back down to its original size. Now, whenever we talk about virtualization, we have virtualized servers. We have server virtualization. This is the process of dividing physical server into multiple unique and isolated virtual servers by means of a software application. Each virtual server can run its own operating system independently. So there are lots of softwares that we use in order to virtualize the servers. Just to give you some examples of virtualization softwares that we use in order to run virtual machines on our computers, you can either use VMware Workstation Player. That's a free version that you can use and install it. It works fine without registering it or without paying for it, since it's only a player. There is a VM Workstation Professional. If you want to have full features of a VMware, you can use VMware Professional in that case. Then we have an option of VirtualBox from Oracle. You can download this version depending what kind of operating system you are using. You'll click on downloads, and here you have different variants of it for Windows host, Mac operating system, Linux, Solaris, and other things. So you can download the software. It would look like this. That's the interface of VirtualBox. And you can set up any virtual machines on it. As you can see, we have installed different operating systems using the VirtualBox. If you want to know about the installation of all the older operating systems like Windows 2.1 all the way since it started, you can get it on our channel. But we are just explaining that how can you use this virtualization software. Make sure whenever you're using any virtualization software that virtualization is enabled in BIOS of your computers. Complete session and the complete videos related to VirtualBox is also available on our channel. So that's VirtualBox. You can virtualize any operating system through this software. Then you can see this is VMware Workstation Player. That's a free version of VMware that you can use, and using this software also you can create the virtual machines. The last option that we have over here is VMware Workstation Professional. That's the version for which you'll have to pay, and you can create different virtual machines using this software as well. There is a complete tutorial about usage of this software available on our channel. Now, just to show you that you can even enable Hyper-V, which comes in with Windows 10, Windows 7 Professional all the way, or Windows 7 Ultimate, and then Windows 10 Professional or 8 Professional. All professional versions will have Hyper-V available in the operating system. You can enable the feature to use it on your computer. Mind it that that feature is not available in the home versions of Microsoft Windows. So I'm using Windows 11. If you want to enable Hyper-V, which is a virtualization software available with Microsoft Windows, you'll have to go to the control panel and then go to Program and Features. And here you'll be able to see turn on features on or off on your computer. And here you'll see an option of Hyper-V. Click on it and press OK. It would install Hyper-V on your computer. So those were different softwares through which we virtualized our machines. Now the benefits of virtualization is it's a rapid creation and removal. So if you have set it up a virtual machine and you're not happy about it, you want to get rid of it, you can easily delete the virtual machine and create a new one. Then it helps in the physical sharing and logical isolation of the computers or the virtual machines. Now if you'll see, we have a traditional architecture and we have a virtual architecture. Traditional architecture is that where you have a computer just like you have at the moment, then there will be an operating system on it which we have installed like Windows 10, 11 or whatever application operating system you're using, and on top of that you'll use any application for virtualization. Whereas in a virtual architecture you'll have a hardware, then you'll have a VMware software or any other software that you're using for virtualization, and using that virtualization you can set up multiple virtual machines. Now the problem in this kind of architecture, in a traditional architecture that we use, is that if somehow the operating system is compromised, your all virtual machines will be compromised. Or if the software which is used for virtualization, we call it a hypervisor, if that's compromised, your all virtual machines will be compromised. So you'll have to take care of it, that how you're setting it up yourself in your environment. We always have type 1 and type 2 hypervisors. Type 1 hypervisor is always a hypervisor where you have a hardware, and on that there will be extra space available for RAM. It would be it would have lots of resources for the CPU. It would have lots of resources of RAM, but it won't have any software or the operating system installed on it, on top of which the software of virtualization is installed. It's a hardware comes with a hypervisor from VMware or any other software that you are using, or a known company, and through which you will be able to create multiple virtual machines, since we'll have a separate storage of it. I'll show you in a minute. So that's how we virtualize the servers. Now advantages further are its server isolation is or consolidation is there, simplified physical infrastructure, reduced hardware and facilities cost, since you'll have one hardware and you'll have multiple machines running on it. It would reduce hardware and facilities cost, greater server versatility and improved management. So you can have multiple virtual machines running on your computer. Make sure that your base station or the host computer is powerful enough to host multiple virtual machines. Now if you have a 32-bit host computer on which you are installing a virtualization software like VirtualBox, VMware or Hyper-V or anything, you will be able to install different variants of operating systems from Linux to Windows Server, Windows XP, or any operating system that you want to install on those operating systems. Now here you can see the difference between a virtualized server. There could be a physical server and then you can have a virtualization software on top of it, but all these servers would have an operating system and an application, but the storage would be shared. It would be a separate storage. The storage is not available on the virtual machines, but all of them would be sharing the shared storage which is available on our infrastructure. Now in this way we can easily upgrade these hosts, which we are calling physical servers, anytime if we want to change the server or upgrade the server. For example, in a VMware environment there is an option of vMotion, and through that you can shift the application and the operating system to a new host just by a few clicks. Now, how virtualized servers, providers use virtualized servers provide invaluable advantage for the cloud providers, including the ability to scale the services and the ability to balance the load to avoid overloading a physical server while other physical servers remain idle. So we have lots of different options through which we make sure that the servers that we are using, they are fully utilized, and it's not like only one server will have all the load. We have different cloud service providers: Amazon Web Services, Dell, Azure, IBM, Google Cloud, you name it. There are lots of cloud service providers available out there. It really depends what kind of business you are in and what you are interested in. You can choose the service accordingly and you'll get the services from there. Now, virtualized servers and customers. To a customer, a virtualized server appears to act like a physical server because it's a virtual server. You'll be able to access it from remote desktop connection. You don't care how it's running. You'll have the resources, you'll have the storage, you'll have the CPU, you'll have the RAM, just like a normal PC that you have. Even if you'll install a virtual server on your machine, you'll be able to access the network from there. Even from your host machine, you'll be able to access the virtual machine. So it would act like a normal machine that you have installed, or a normal installation that you conduct, or you install it on a laptop or a desktop computer. Ease of creating and deploying the services, rapid scaling, and safe and rapid testing. Now we are just giving you an example over here for Amazon Web Services. Its management console, that how can you install a virtual instance using a cloud service provider. In our case today, we are checking Amazon Web Services. So once you log in, you'll have an instance which you can launch by clicking on launch a virtual instance. Then it would ask you from a set of operating systems. It would show you a list of different operating systems, and if you want to install a 32-bit or a 64-bit variant of it, as you can see, SUSE Linux or Ubuntu or Windows Server and Windows 10, Windows 11, lots of different operating systems will be available over here. All you need to do is select it and select the operating system by clicking on the select button. Then you'll be able to select the tier like the different CPUs and other resources utilization, which you can choose the instance type from here. Like you can see, we have selected one with 1 GB RAM. You have even with 32 gigs of RAM and 8 CPUs. Further resources are available, but mind it, the highest tier you'll go for, you'll be billed according to that. Since it's a virtual environment, they are giving you the services for what you'll pay. If you need powerful servers for your applications and stuff, you can select the option accordingly. Then in next, they are asking that how many instances you want to create. We are selecting only one, and then you can select the network, subnet, and other things which you want to change according to your setup. But in a normal setup, if you're testing it only, you can keep it as it is and just proceed to the next option. Now here you can see it's a root volume. There is a snapshot, and we are selecting a hard drive of 30 GB. You can select it according to your own resources or the application that you are going to install on it. And again, you'll be billed for the bigger or the more capacity you'll choose for your virtual machines. Here they are asking that how you would like to access your server. It's a remote desktop connection, and as you can see, 3389 is the port for remote desktop connection, and you'll select the settings, and then it would review. It would show you an option that's the review of your overall setup, whatever you have selected, and you'll launch the instance by selecting a pair of keys, how you want to access the server and all those things, and that's how you launch the service in order to launch your virtual machine. So that's how easy it is through the web-based interface, how you can select the services and how can you load different services or an instance using Amazon Cloud Services. It would show you that these instances are running on your computer, and the running status would be shown over here, that there are no alarms and everything is working fine. Now we have different cloud deployment models. Whenever we talk about cloud deployment models, we have public cloud, we have private cloud, and we have hybrid cloud. Now, public cloud is a open cloud, multi-tenancy. Everyone can be there. Different users are using the same cloud. Then we have a private cloud, which is provisioned for exclusive use for a single organization. If you want to shift your data center to the cloud, you'll have a private cloud of your own, and you'll have all your servers, operations, applications, each and everything will be in that private cloud. Then you have a hybrid cloud, which is a mixture of public and private cloud, communicated over encrypted channels. Always portability of data applications, security of the connection is there. So multiple users can use the hybrid cloud together, or if you want to keep certain services in public cloud and certain services on private cloud, you can do that. Now, just to give you an example, very common, which is available everywhere around on the internet as well, that a public cloud is just like a bus. It is accessible to everyone. No one owns it. Everyone utilizes one big service which is served, and it's up to you if you want to avail the service. You'll pay a minimum charge and you can host your things in that public cloud and avail the services. Private cloud is just like owning your own car. You have your own things. You'll do whatever you want to do. You'll drive it wherever you want to drive. You'll keep your own applications. You'll install the applications as per your own requirements. No one has any access to it. Only you alone would be utilizing it. So that's a private cloud. A hybrid cloud is like a taxi, where you rent a taxi, private taxi, it would take you over there, or you can use it for your own. Or it would be used by different public, but depending that what kind of service is it, it would be segregated depending on the applications and other things which are hosted on that hybrid cloud. So that's a cloud service models. We have software as a service, platform as a service, or infrastructure as a service. In software as a service, we are talking about the server, storage, network, operating system, middleware, and package software, and end users will be able to use it. Now, platform as a service, which is have the server, storage, network, operating system, and middleware. Usually the software developers are using platform as a service. Then we have infrastructure as a service, where we'll have the server, storage, network, and infrastructure architecture supported on that, so we can rely on the services which are there on the infrastructure. Now, just to summarize it over here, a software distribution model in which applications are hosted by a vendor or a service provider and made available to the customer over the internet is software as a service. For example, billing invoices, customer relationship model, help desk support applications, human resource applications. Office 365 is an example of a software as a service. Then you have a Dropbox, lots of other services which are hosted, and you can pay and avail the services over there through the internet. You don't need to own anything. You don't need to pay for the licensing fee of the softwares which are being used. You'll pay for the service that you are utilizing, and it would be hosted in the cloud. Then we have platform as a service. It provides a runtime environment for application development and deployment tools, provides the facilities required to support the complete lifecycle building and developing web applications. So it is basically used for developing and using the applications which are hosted in the cloud. Now, applications engine of Google, for example, or Salesforce are an example of it. Then perform with tool sets, develop host applications, manage security, operating system space, backups, collaborative work. All those features are available on platform as a service. Now, keep in mind that when we are talking about app engine of Google, just like that, there are different app engines for Amazon, for Microsoft Azure services, Azure Cloud, and different other cloud providers. Now, they are facilitating you by their own tools and toolkits which are available on their cloud, so that you can easily create applications using those toolkits which are available with that cloud service provider. Now, most of the times it happens that certain applications which are developed, for example, on Google, cannot be easily migrated to other platforms because they are not built for that. Now, there are different middlewares available through which you can migrate it, but mostly just keep in mind that if you want to develop certain applications using a platform, it's recommended to stick to that platform, so that you you can easily avail the services which are provided by there. Then we have infrastructure as a service, provide access to fundamental resources such as physical machines, virtual machines, or virtual storage. Amazon Web Services, GoGrid, from Microsoft, we have Microsoft Cloud itself, Azure Services, which we call. Then we have Google Cloud. The features that it will have: virtual disk space, virtual LAN, load balancers, IP address, and software bundles, etc. that you can select on it. Now that's in a nutshell when we talk about cloud service providers. The dark blue color is talking about things which are managed by the user, whereas the light blue color things are the items which are managed by the service provider. Now, if we have a data center on premises, we are taking care of application, we are taking care of data, runtime, middleware, operating system, virtualization, networking, storage, servers. It's even more than that, that you are totally responsible for the backups, you are totally responsible for the power supply, cooling, maintenance, upgrade, electricity charges, replacement charges. Each and everything is your own responsibility. Whereas in infrastructure as a service, if we'll think, the things which the user will be responsible for will be the application, data, runtime, middleware, and the operating system. Rest of the things like the virtualization, networking, storage, and servers, etc. will be handled by the cloud service provider. If we'll talk about platform as a service, which is used for application development and hosting, etc., in that, application and data is your responsibility. You'll be working on it. Whereas the runtime, middleware, operating system, virtualization, networking, storage, and servers would be the responsibility of the cloud service provider wherever your services are hosted. Whereas in software as a service, complete responsibility falls on the service provider, including the application, data, runtime, middleware, operating system, virtualization, networking, storage, and servers. So if you want to avail any services for your organization and you don't want to invest anything on the infrastructure, or you don't want to take care of anything, you want to rely 100% on the cloud service provider, you'll go for software as a service. Now here they are again trying to explain the same thing, that if you're talking about infrastructure as a service, operating system, storage, network, firewalls, and physical data center would be included. If we are talking about platform as a service, we'll add the development tools and data management. Further, physical data would be there. If you're talking about the software as a service, we'll have the hosted application and we'll have the physical data center, which would be included as part of it. Now in our next lectures, we'll look in detail about software as a service, platform as a service, and infrastructure as a service. So that was our chapter on elastic computing advantages. Kindly subscribe to the channel, leave the comments so that we can improve the lectures. That's it for today. Thank you very much.